Hi there, welcome to Epiroi Academy. In this video, we are looking at application of calculus. Our focus is on velocity and acceleration. At this point, I should assume you know how to differentiate and maybe you have some knowledge of integration. But velocity and acceleration is really linked to differentiation. So we're going to focus on differentiation. Having said that, let us begin. So there are two formulas that you need to know by heart before you start dealing with velocity and acceleration. To find velocity, v, you are going to differentiate, or you're going to find the derivative of distance with respect to time. So velocity is equal to ds dt. That is the derivative of s, which is distance, with respect to time. So you have to know this by heart. This is our first formula. Our second formula is that to find acceleration, sorry, I'm supposed to write a here, not equals. To find acceleration, you are going to find dv, the derivative of velocity with respect to time. The derivative of velocity with respect to time. What it means here is that you are going to differentiate a given function twice, or this is equivalent to d2 s dt squared. So it is the second derivative of a given function. A second derivative of a given function. So I find this to be more direct than this one. This one could be a bit confusing, but the meaning is the same. Because what you're saying is, given a function of distance, you're going to differentiate it for you to find velocity. Now, for you to find acceleration, you're going to differentiate what you have already differentiated to find acceleration. So you're basically differentiating a function that has been differentiated already. I hope that is clear. So now, let's assume we have this function of distance. So actually s here is distance, it's not speed. So distance, sometimes s is used, or x, or d. So those are the letters that are most common. So s is equal to So given the following functions of distance, find v and a, that is find velocity and acceleration. Or find the functions that relate to velocity and acceleration. So what you're going to find is really a function, not really the value of velocity and acceleration. We are finding the functions that relate to velocity and acceleration. So that is how the question was supposed to be read. Given the following functions of distance, find the functions. So we're finding the functions, not the values of acceleration and velocity. So s distance is equal to t squared minus kt. So we are saying to find velocity, v is equal to ds dt, the derivative of s with respect to t, which is equal to, so when differentiating, we say you subtract the powers, right? You drop the power and you subtract it by 1, you minus 1. So this will be 2, you drop the power, and you subtract 1 from the power. So here we have a power 1, which is silent. Minus, so what's our power here? It is 1. So we drop 1, multiply it by whatever number is on the coefficient, which is k here, and we subtract the power, we subtract 1 from the power. So we're going to remain with k. So 2t minus k is a function that relates to velocity. So this is the function of velocity. So now let us find a function of acceleration. So acceleration, we're saying this is equal to dv dt, or the second derivative of the function of distance. So we are going to differentiate what we have differentiated here. So this is what I was saying earlier. So dv dt is equal to, so here we don't have any power, so this, it will come there, so we have 2. So now this is a constant, which is just equal to 0. So actually acceleration, we are finding it to be a value, but it's not always that you're going to have acceleration as a value. It's not always. So there you have it. So we have found acceleration, we have also found velocity. Let's look at another example. S is equal to t squared minus 3t plus 2. So to find a function that relates velocity, we are going to say v is equal to ds dt, which is equal to 2t minus 3. Acceleration will be equal to dv dt, which is equal to, wow, we found 2 again. 2, now this is a constant, 3 is a constant, so which is just equal to 0. Okay, now let us look at another function of s where we are not going to have acceleration as a constant, because this 2 is constant. So let us look at this one. S is equal to 2t cubed minus 15t squared plus 4t plus 3. So to find velocity, velocity is equal to ds dt, which is equal to, so we drop the power, multiply by the coefficient. So we have 6t, so we subtract 1 from the power, squared, minus, we drop the power, multiply by the coefficient. We have 30t, we subtract 1 from the power. What do we have? We have t, we have 1, plus 4. That is, we drop the power multiplied by coefficient, we get 4, and then we subtract by 1, so we're going to have 0 there. So any number raised to the power of 0 is 1. So this is our velocity. Now to find acceleration, we are saying we find dv dt, or the derivative of t with respect to t, which is equal to, so we drop the power, so we have 12t minus, so we're going to remain with 1 on top there, minus, so here we're going to remain with 30. So I was just showing that's not always where you have a constant like we had in the previous examples. Okay, so in this video, I just wanted us to do an introduction to velocity and acceleration so that we can warm up. So in the next video, we are going to go further looking at problems of velocity and acceleration, how you can use calculus to find velocity and acceleration. Thank you very much for your time. Remember to subscribe to our YouTube channel and like our Facebook page. Thank you. If you're not clear, you can always reach to us. You can send us your questions and you'll be attended to. Thank you.